So it's a brand new talk. I try to mix up my talks quite a bit, and so that's a lot of work. But and sometimes it's like, so for you guys, especially Kyle and Dion and Thomas, it'll be good that it's a new talk, but I have no idea how long it's going to be. And my guess is it's going to be more long than short. And I don't know how, I think it's going to go pretty smooth, but we'll see. But so it's a new talk, so that's kind of fun to unveil a new talk. And I've got URLs here, just so you know, this is my website. I specialize in UI design. And you can see here, I've got all my talks, and the slides are right there. And I also just post them on SlideShare. So you can follow along however you want. But it's like a 20 meg slide deck. So it's big to download. OK, so let's dig in. So at some point, I'm going to feel like I don't have to introduce myself, but I'm not at that point yet. So I'm Steve Souders. I work on web performance. I used to work at Yahoo. I was the chief performance Yahoo. While I was there, I created Why Slow, and I wrote this book, High Performance Websites. And I've been at Google. I was at Yahoo for 8 years, and now I've been at Google over 2 years, about 2.5 years. While I was there, I wrote Even Faster Websites. It's like a volume 2. I taught a class based on the books at Stanford. I started the Velocity Conference with O'Reilly, so I'm the co-chair of that. And in addition to Why Slow, I've released Hammerhead, Kazillion, SpriteMe, and BrowserScope. Actually, I did UA Profiler, and then it morphed into BrowserScope. I'll have a quick slide about that later. And I think the number one thing, I've worked in this area for 4 or 5 years. I actually started working on the web on the back end. So I ran my Yahoo team for 3 years at Yahoo. I worked on Yahoo's worldwide user database. I added stored procedures to that database. And the concept of me writing that C++ code now, I mean, it just scares me that I actually did that and that code's running. So then about 5 years ago, a couple folks at Yahoo asked me to start working on performance because I'd been there a while and worked across a lot of the different architectures and knew a bit about it. And I thought this was going to be about back-end performance, about optimizing server load and Apache and things like that. And they said, no, what we want is and it was basically just this one exec, Jeff Ralston was the chief product officer. He personally was mad that when he went home and he used the Yahoo products, Yahoo Mail and My Yahoo, that they were slow. And he wanted them to be faster. And I think that's very cool. I think that kind of bringing your personal likes and dislikes and vendettas to work, makes you emotional about things. And so he was very passionate about this. And so I started the Exceptional Performance group there to really focus on performance from the perspective of the end user experience. How fast or slow do these web apps, do these web pages appear in front of users? And so I think the number one thing that I've contributed to this space is what I call kind of flipping the perspective upside down. So certainly like those years that I was working on the back end, when someone would complain about my Yahoo being too slow, we would look at the Apache logs and look at how long it was taking Apache to get that first byte off the server, right? And if we could, reduce 220 milliseconds to, 200 milliseconds, a 10% improvement, that was pretty good. And that was usually several months of work of, compiler optimizations and database optimizations. And then when they said, well, no, we really want to focus on the end user perspective, I fired up a packet sniffer and I loaded my Yahoo. Now I load iGoogle. And I saw a picture like this with an empty cache, usually like 10 to 20% for most websites, is getting the HTML document. And this is where most of our back-end work is going on. Certainly today we're getting more web apps, and so there's some later JSON or dynamic JavaScript that's being generated on the back-end server. But by and large, the rest of these HTTP requests are static resources that are in memory on the server or might even be served from a CDN. And so there is network time, but from what we've seen from some of my research and work that other people are doing, there are ways to address network time, certainly reducing size of resources. And so this is what I saw 5 years ago, and I still see it pretty much, is 10 to 20% of the empty cache time is spent on getting the HTML document where all that back-end work is going on. So there's all this front-end work. And then even with a prime cache, you'll still see about that same ratio. 10 to 20% is spent on the back-end HTML document. In this case, there's only one other HTTP request that's being done, but there's all this white space in the middle where all of those other resources are being read from cache. The CSS is being parsed and applied. The JavaScript is being parsed and executed. And so it's a big white gap where no network traffic is happening, but it's still consuming over 80% of the end user experience. So I think I have gotten companies like Yahoo and Google and other companies to realize that even though maybe the hardcore programmers in those companies in the early days were these back-end C++ scalability gurus, really if you want to make the experience faster for end users, you've got to flip it upside down and you've got to focus on the front end. And so that's been very exciting to be a part of the growth of this front-end developer career that is coming about. Okay, so that's me. Okay, now I'll launch into the talk. So there's like 5 things I'm going to talk about. So a week ago Friday, like my dream came true. Like, you know, I could retire now and be happy. So Google announced that site speed is being taken into consideration for search rank. So this is going to, and it already has, is going to put a lot of companies, going to get them to put a lot of focus on performance. And that's just for me, like I'm kind of like Jeff Ralston, like I just get really, really frustrated if I'm surfing the web and I have to wait. And certainly like for some things, if I'm booking air travel or something, I'll wait a little longer. But for things like Twitter, like it should be instantaneous. And if it's not, like I find that really frustrating. And so I want that better user experience to propagate across the entire internet. And luckily, Google is aligned with that very well. So they like hired me and they pay me money to go and do talks and research. And now they're backing it up by putting it into search rank. And one of the reactions, we actually announced something like this 2 years ago for the AdWords quality score. And the typical reaction there, and I'm seeing it with this announcement as well, is doesn't this really favor larger companies that have bigger development teams to focus on performance? And from working with big development teams at big companies for the last 5 years, I can tell you it's just the opposite. The big teams have that web page is distributed across multiple separate development teams. And some of the code that's running there is legacy code that no one touches anymore. And so to make a change, even a simple change, like move this script tag from here to here, can take months. Whereas I get contacted 20 times a week from small companies with questions, and I'll say, small and big, and I'll say, well, why don't you just move that script tag down? And like 2 days later, that person at a small to mid-sized company has made that change and emailed me back with the results of it. Like that's how fast, that's how agile these small companies can be. And so I actually think this bodes well for the small, more agile companies out there. But certainly I think it's going to result in some more emphasis on performance. And I thought it was very cool in this blog post, they pointed out 2 Google things and then a couple other things, 2 other tools, Why Slow and Web Page Test. So I wanted to highlight those really quick. I'll start with the 4th one there, the Webmaster Tools. How many people here use Webmaster Tools from Google? So like I hadn't used it before this announcement, so I signed up for my site, stevesouders.com, and we can talk offline about why it's in the red zone most of the time. But I can get this report of how fast or slow my website is. So where does this come from? So we announced all of this in the blog post and other blogs. Unfortunately, I don't think we collated, aggregated all of that information as clearly as we could. So I see these questions being asked in the comments in the blog post. So we said that the way this data is gathered is from the end user. So what we do is in Google Toolbar, if you opt into the PageRank privacy options, one of the pieces of data that we send back, that the toolbar sends back, is the overall page load time. And that's from the point where the user requested it to the onload event, right? So we're getting this for real users for your site out there, and now we're sharing it with you, right? So you can only see your site. You can't see other people's sites or competitors' sites. You can only see the site that you're the webmaster for. but we can show you where you are relative to other websites on the internet. So this is very valuable. It's not that hard, but for certainly mid to small companies, it can be difficult to put some kind of JavaScript timer in there, collect all those beacons back, and put stats, generate charts from that. So it's kind of nice that Google is offering that up. And if you scroll down, you'll actually see some of the page speed, Google page speed output, giving you some tips on some of the low-hanging fruit you can do to optimize your site. So that's a good segue into, people always ask me, maybe because I did YSlow and now I'm at Google, which one they should run, and I always say you should run them both. Whenever I'm looking at a site, I run them both. There is certainly a lot of overlap. There's about now, and this slide is actually about 3 months old, so I think there's 5 or 6 new rules that have been added. But there's about 50 rules total that have been added, about 30, 35 of them, both of them check. But then there's other rules, important rules, like do you have an opportunity to do spriting, or are you not executing a lot of your JavaScript that you download? There are a lot of significant rules that only one or the other checks. So you should really run both and look at the recommendations from both. And then the other tool that was mentioned there was webpagetest.org. How many people have used webpagetest.org? So I'm going to do that live right now. So let's see, you go here. This is, so there's an AOL tool called AOL Page Test. That's a Windows executable that's a plug-in to IE. And so you can run it, and it gives you like a packet sniffer output and some YSlow-like performance analysis. And then what this guy right here in Reston, Virginia did, Patrick Meenan, was he spun up some servers in his basement about 2 years ago and running IIS and just connected that to Internet Explorer. So you can go in through this website and you can punch in a URL. So I think this is a really great form factor. I have to squat down to get the right angle. Okay, there we go. Just do that. And you can pick, so it's all open source, so other companies have actually spun up instances around the world. So you can pick other instances, choose IE7 or IE8, what kind of connection you want. I'm just going to do one page view, first view only. And I'm also going to click this other thing over here. I think you have to create an account for that to be available. I'll hit submit. Takes a little bit. Let's see. Okay, I guess I'll go on while that's running. So this is the results that we'll see in a minute, but I'll just go back there and show it to you live. So what people ask is, especially now, these people who care about search rank, they say, okay, so where am I supposed to focus? And they correctly identify ads and other widgets as a performance problem. And the story I say here is, when I started like 5 years ago, and I went to development teams and I said, hey, I'm here to help you make your website faster. They said, oh, well, it's really not us, it's the ads that we're running. And so I would look, 5 years ago, I would look at I had an early version of YSlow and a packet sniffer, and I would look at what was going on, and I'd say, well, yeah, certainly the ads are doing some bad things, but if we look at the pie of bad things being done in this page, the ads are like 20%. Like really 80% of the bad things, the low-hanging fruit, is your code. So before we people in glass houses shouldn't throw stones. Before we complain about the ads, why don't we clean up the other 80%? So we're seeing pretty good adoption with that. But what's happened, so because of that, the size of that pie has shrunk down, but the size of that bad performance stuff from ads has stayed the same, and it's actually increased because now we're getting more widgets into pages and analytics, other third-party content that websites don't control. So now third-party content is a big, big issue in today's websites. So I started this project about 2 months ago called P3PC, Performance of Third-Party Content. And you can see now why most of my slides have a background that's really fast, but this is a snail, because these ads, widgets, and analytics have a really negative impact on a website's performance. So I'm going to go back here now. Okay, it's done. So you get some overall stats. They do some YSlow grading, like I was saying, some things they check. You can click on these things, so it gives you a picture, some optimizations. You can click on this waterfall, HTTP waterfall chart, click on any of these, get all the headers. So the cool thing about this is I haven't had to install anything on my machine. So if I don't have IE, or if I'm like someone in marketing or biz dev, and I don't do that stuff, I can still get a picture of this. The bad thing is it's only IE, but IE right now is the #1 browser, so it lets anyone, regardless of what browser they use for development, to get a picture of what's happening in the most popular browser out there. And then I did that, I clicked that video box. So this was something I worked with Patrick on. Let's see, how do I get to it? Oh, I think I have to go back another one, yeah. Okay, here we go. So I can do this film strip view. You'll actually see this again in a minute. So he shows me at whatever interval I want to check. He shows me what the screen looks like at that interval. And I can also watch a video. Let's see, there's a way here. Here I can do a slow motion video if I want. And you can actually do this for multiple websites and show them all side by side, whether you do the film strip view or the video view. And the cool thing about the video view side by side is he doesn't have 2 videos and he tries to start them simultaneously, which would be impossible. He actually does the work on the back-end server. He can combine, I think, up to 8 or 9 videos all into one video. So they all start at the exact same time, and you can see them side by side. And you talk about an impact. You show that to someone in management or marketing about how your website loads against a competitor, and it's very, very compelling. So I recommend webpagetest.org. Okay, so third-party content is having a big impact. So these are the analyses I've done so far. And so I come up with a subjective grade that I give them, small, medium, or large. I just record the page speed and Y-slow scores here. Whether or not they use document write, that's a big problem. We want to move away from that, and some other stats. And certainly what we see here, except for the dig widget, all the other big impacts so far are ads. And then there's a medium, which is an ad. There's one ad that's a small impact, and that's buy-sell ads, where they've actually adopted an asynchronous way of loading the ad JavaScript, so it doesn't block the page. So I'll keep going on with this, and there's another reason why I'm doing this besides highlighting some of these places that we need to clean up out there on the web, try to motivate people to clean up what they're doing. The dig guys, I'm always amazed. I try to be very speak softly when I level this constructive criticism. I'm always so excited when people respond in a positive way. So like the next day, someone from Dig contacted me and said, hey, we've been working on a rewrite for that. It was great to hear your suggestions. Would you look at the new code that we're doing and do a review before we release it? So pretty much, except for the ad people, people are pretty receptive to this and excited about speeding things up. So let's see. So a slight tangent. I feel more and more like I'm doing marketing stuff with lots of pictures. So I still wanted to do some. I really like it if people have some takeaways and some code to think about. So a lot of these widgets that are doing things faster, and a lot of the advanced JavaScript performance stuff we saw today, talked about loading scripts dynamically. So like as I'm going through all these widgets, I'm seeing a lot of different ways of doing that. So this is the way I suggested doing it in my book and examples from 2008. Just get the head and append the dynamically created script to it, right? So it turns out there are some problems with this. Not all documents have a head. Most browsers will create a head even if one isn't in the HTML, but not all browsers do that. And then there's this IE bug if you have an open base tag and you try to append child to head. So naively, this was the way I did it, and it worked fine in my examples back in 2008. Google Analytics, I was very excited to see in December because it's used a lot. It's got this JavaScript file. The old pattern did a document.write, which blocks everything else in the page. And it's like, we're Google. We're trying to suggest people make their websites faster. Like, why don't we clean up our act a little bit? So in December, we announced this asynchronous way of loading Google Analytics. And this was the way they did it. They got the document element first child, append child. And it turned out that had some, in these edge case pages had some bugs. So now this is what they've just moved to recently, this insertBefore pattern, which I think is probably the most robust way to do that. But I wanted to look at some other examples. So I looked at the YUI loader. I don't know I think Adam's talking in the other room. Is Tom here? I don't know what, I tried to figure out what the insert before logic was, and I couldn't quite figure it out. But in some cases, they're doing insert before if they detect under some conditions that I couldn't figure out that that's available. Otherwise, they do appendChild, so they're taking kind of a hybrid approach. I saw the presentation this morning from Facebook. So while I was sitting there, see the April 18th, 2010? While I was sitting there, I went and looked at their code and saw that they're doing so they get this hard point, and basically that's doing a head or body, right? So that's going to return head if it's there or body. And then they're creating the element dynamically, and they're calling it appendChild. So I would guess if they had a page that had an open base tag, it would have problems in IE. But they're not building something like jQuery that's going to be plugged into pages that they've never seen before. They're using this in their own pages, and they make sure they don't have an open base tag. They might want to look at this and think about doing it in a more robust way. And I looked at jQuery. So is John here? Oh, man. I'm such a Resig fanboy. I saw his code. And it's beautiful. Or I don't know if he wrote it. It's in jQuery, and it's beautiful. So without adding a lot of comments, so I, of course, looked at the unminified version. They're getting the head or document element, and then they're inserting it before the head first child. So I haven't seen this pattern before. My guess is this is the most robust pattern you could have because jQuery is used so many places. And the thing I really like about it is these comments where he not only mentions this IE bug, but he actually has references to the, he or they, the jQuery community, have references to the bug numbers. So I thought that was very powerful and beautiful. And I want to show you the antithesis of that. Collective media, can anyone guess what they do? Well, I mean, what business are they in? Ads, oh my gosh. Bad performance from ads. Who would have ever guessed? Okay, so let's walk through their code really quick. So it's looking pretty good so far, okay? They're going to get all of the scripts in the page, right? This is what Google Analytics does. I mean, it's pretty robust. Get all the scripts in the page because you know there's got to be a script in the page because you're in a script tag. And then you can just append, whether it's in the body or head, it doesn't matter. Just append to its insert before into its parents. So then they find the last script. B is the last script in the page. I added these comments. They check if it's null. Could have done that better. They create a dynamic script. You don't really need to set the language. You don't need to set the type. They could have done this setting J as one line instead of creating an empty string and then appending to it. And now it's starting to look a little sketchy because this string that they've created is doing a document.write, and it's breaking the script tag, which we know we don't need to do, and it's got the source right here as a variable. So we've seen all these other patterns where you create a dynamic script and you just set its source, but instead they're putting that script source inside a document.write line in a script tag in a string. Okay, so where's this going to go? All right. Okay. I wouldn't have guessed that. I wouldn't have guessed the next line would have been create text node, but they're creating a text node, and we'll see that that's never used in the rest of the code. But just to be safe, okay, and then they're inserting it. Okay, so they're inserting this new script tag, which right now is empty, in front of the last script in the page, but the script is empty. And I've got this J dangling there. What's going to happen now? Okay, we're going to call appendChild. Oh, but wait, this looks like a different appendChild. Oh yeah, sure enough, in the global scope, they've defined a function called appendChild, and it checks for this IE thing about can have children, and in that case, it will append. Now it's passing in the text node. Oh no, it's passing in the string, ij, b is the string. So it's going to create a text node again. So my guess is they forgot to take the create text node out up there because they now put it down here. If they can append child, they do that and they create a text node wrapping this document.write of a script tag. Otherwise, they just set the text of the dynamically added script to this JavaScript line that's going to do a document.write to fetch an external script. Oh my gosh. It gets worse. So this code that you're looking at right here is in this script. To get to that script, I had my HTML document that had their snippet that did a document.write for an external script. That external script returned a redirect to this, which returned a redirect to this, which did a document.write for this code that now contains this document.write to insert the actual ad, which then fetches the actual double-click ad. So by doing it that way, with all these document.writes and external scripts and redirects, I've got 5 HTTP requests that are done sequentially, right? So why would they possibly pick a code pattern like this? I've got 2 ideas. One is, like, they just, God bless them, they just don't know JavaScript that well. They should get the Jupyter guys, good candidate for you to contact as a potential client. They don't know what they're doing, or they explicitly wanted this double-click script to load in a blocking fashion. So think about that. If you wanted to load a script and you had to load it dynamically, I gave you a source and you had to dynamically load that, and you wanted to dynamically create that script in a way that would block everything else in the page, this is the only way I can think of to do it. I mean, slight variations, but you got to do a document.write. And then that will guarantee to block everything else in the page. So either they don't really know what they're doing, or they really know what they're doing. But the end result is the user experience is kind of hosed. So it's scary looking at this third-party content. There's all this stuff out there. I've got till 3. What time did I start? I have till 3:30. Okay, 15 minutes. I got to go faster. So there's some scary stuff out there. What we need is a way to take that scary stuff and just make it faster. So we do this thing called Velocity Summit every year. And we were sitting around at the last session back in January, and we were like, what can we think of? So what are the big problems on the web, and what can we do to fix them to make the web faster? And so we brought up third-party content. Ads especially can be really slow. What can we do to improve that? And Alex Russell said, well, what if we put them in something kind of like a document fragment that was kind of separated from the rest of the page? Because right now, this third-party content can really hose your main page. It can block all of the critical content, mess with the CSS, mess with the JavaScript. What if we put it in this kind of frag tag thing? And it was like, oh, that's quite kind of cool. So we could have like a really slow snippet, and we could put it in this frag thing and make it really fast. Like, that would be cool to speed things up. So maybe you have a snippet that you get from your ad provider or widget provider, and this snippet.js will do slow stuff, document.write, and blah, blah, blah. And all you have to do as a developer, as the owner of that web page, is put an open-close frag around it, right? So this is just a new idea. We haven't even written anything about how it would work. We've had a couple discussions about it. One key thing is anything in that frag doesn't block the rendering of the rest of the page. It can support an asynchronous document.write, so even though the browser is continued to plow on, rendering the rest of the page, and finally this JavaScript, snippet.js, comes back after a few redirects and does a document.write, that's going to work out just fine. The browser will handle that. We could even add like a sandbox, like we've got now in iframe for HTML5. We could add a sandbox attribute to this frag. And so initially, for better or worse, a lot of these pieces of third-party content require access to the global JavaScript namespace in the main page. And we certainly don't want that. And some widgets aren't supposed to be doing that. Some ads aren't supposed to be doing that. But right now, they do that. And to work, they would have to do that. So maybe initially, the way I see this rolling out is website owners just do this. They have some widget or ad snippet, and they wrap it in a frag tag. And now the rest of their page can plow on and be super fast, and the ad and everything still works, right? And then what's going to happen? One of these snippets is going to do some nefarious thing. And some publisher is going to say, that's it, I'm done. I'm saying sandbox. And I don't care if 5% or 25% of my ads don't work. I don't want to have that happen to my users again. So then we're going to start seeing frag sandbox equals true, right? And all these publishers are going to be doing that. And eventually, these snippet owners, primarily ad networks, are going to have to clean up their act. And then what's going to happen? Alex Russell just walked in. And then what's going to happen? Your name is on the slide. And then what's going to happen? The snippet providers themselves are going to wrap their snippets in a frag tag. So like I said, this is a brand new idea. Nothing's been written about it. We've had a couple of conversations about it. I say it's just a twinkle in my eye. Really, I think hope it's more of a twinkle in Alex's eye. So I recommend that you corner him and ask him a lot of questions about this and tell him how excited you would be to see this happen. I think if we had this frag tag, it would be one of the biggest things that website owners could do to improve the performance of their pages. So I really hope we see that happen. I added that. I did this blog post in February with my browser wish list, and I had frag tag was either number 1 or number 2. And I came up with this long list of recommendations for browser vendors. And I could do a whole talk on these, but I'd rather talk about something that's not on this list. And that's taking hardware that we have and taking advantage of it to the fullest. So what am I talking about? I'm talking about the browser disk cache. So if we look, believe it or not, like most browsers haven't looked at what they set their cache sizes to 5 years ago. And so I'm pretty sure of these, i.e., you can set it higher, but the default will be somewhere between 8 and 50, depending on your disk size. Firefox is just hardwired to 50. Chrome has this kind of step function, but generally it'll be somewhere between 10 and 80 megabytes. So if you think about it, most of us have hundreds of megabytes or several gig of disk space available. We're surfing all the time. We'd love to have all of those big JavaScript files in our cache when we go back to a website. Please by default, take a gig of my disk space or 500 meg or something like that for the cache. So that's one thing we need to fix. The other thing is the eviction algorithms. So like we're learning more and more about how important different signals are when it comes to web performance and these resources, these assets. So as far as I know, I don't think any of these eviction algorithms look at the content type of a resource. So a script and an image are considered equally valuable. Well, you know what? Like images aren't blocking the rendering of my page and aren't blocking other downloads. I'd like them to have a little higher priority so they get evicted less often. So I think we can do things like maybe we could track, yeah, this image maybe I don't put a lot of value on, but last time I downloaded it, it took 10 seconds. So I'm definitely going to cache that one longer. And maybe there are sites that I go to. I haven't been there in 3 days, but for the last month I went there every day. Like it's officially one of my preferred sites. Don't ever purge the cache of the resources from that site. So I think we could do things to improve browser disk cache. And I've talked with a bunch of the browser vendors about this, and I think we're going to see movement there. So go here to stevesouders.com/cache.php, and I'll go ahead and show you. So I tell you how to find the available, right now I only did IE, Firefox, and Chrome, but I tell you how to find out how much disk space is the max and what you're currently using, and then I ask you to go to this survey and input your numbers. And so what I want to do is, we don't have an easy way of measuring this from the server side, so I just thought I would take a sampling here, and if people would try to do this before the day's out. Don't do it right now because I'm saying some really important stuff. But maybe in the next talk, you could go in and fill that in. So okay, I'm close to wrapping up. Not really, but so I want to talk a little bit about stepping away from code and some of this hard instrumentation and get back to the real thing. In that first meeting I had at Yahoo 5 years ago, Jeff Ralston said, well, how can we measure how fast or slow our pages are? And I thought, well, we could do this thing where we, figure out, instrument the onload event for our websites and measure this onload time. And so I kind of say that, and he goes, well, really what we want to measure is the user perception. I'm like, yeah, but, until we get that, onload brain event handler, we can't track that, across all our websites. So, and it's, especially at Yahoo, we have such a variety of web pages. You can't pick something like an image or something like that that renders as an onload time. So thinking about that, it's that user perception. What is it that really makes websites feel slow? It's the lack of progressive rendering, right? So that was 3 seconds, right? It sounds like a lot, okay? So let's go back to web page test. Here I've got the major search engines, and I'm doing a 500 millisecond, a half-second step interval. And we can see the difference in the progressive rendering. So Google's at, and these are sorted by market share. So I love seeing a distribution like this, where we're in the upper right quadrant. This argues that performance pays off for market share at least, right? So, and I think it's not surprising that we're seeing that kind of clumping when it comes to search, because speed is a real competitive factor when it comes to search. News, not so much, right? So CNN is number 2, and here I'm doing a 1 second interval. So at 4 seconds, nothing has rendered, right? So that slide that came up just a minute ago was 3 seconds, and it seemed kind of long. Well, here's 4 seconds. Nothing's been displayed for CNN. Shopping is kind of in the upper right quadrant, but here it's a 2 second interval. So we have some of them aren't done until 8 seconds. The top one isn't done until 8 seconds, and Best Buy and Target are only partially rendered at 8 seconds. Same thing with sports. We're at a 2 second interval. So at 4 seconds, none of them are fully rendered, right? So it's getting stuff in front of the user as quickly as possible. It seems obvious, but when I'm looking at websites out there, web apps out there, I'm really not seeing acknowledgement of that problem. And so what I'm talking about here with progressive enhancement is what is most critical for the user to see, put in the HTML document as HTML and get it in front of them as quickly as possible. Defer as much JavaScript as you can, try to touch the DOM as little as possible, and then enhance the page with your JavaScript loaded after the main content of the page has appeared, much like the Facebook talk today. And if you do that, you're going to get progressive rendering. You're going to get this JavaScript out of the way. So we all know it, but why do you focus on JavaScript? These slides are old, so you won't see this now. All the Facebook JavaScript has gotten out of the way. These are about 6 months old. But when I've circled the JavaScript, you can see that it has a disproportional negative impact on the page load, right? And that's because scripts block. So this is just a test page. It has 2 scripts that take 2 seconds to download, 2 seconds to execute. So you can see what's happening here. 2, 4, 6, 8, and then each of these, an image, a style sheet, and an iframe are 1 second. So this takes 9 seconds to load in the kind of older browsers. But even in the newer browsers, it's not as optimized as we'd like. We've got 2 seconds for the scripts, 2 seconds for the first one to execute, 2 seconds for the second one to execute, and then 1 more second. Well, in these newer browsers, they do parallel script downloads. How come these are dangling out here? And it's just bugs, and in their speculative parsing, they haven't looked far enough, or they haven't recognized the iframe tag. What we really want is we want all the resources up to the number of connection limit to be downloaded in parallel and not have scripts have this blocking download effect. So there's still a motivation to optimize your JavaScript downloads, even for the newer generation of browsers. So here's another. I just updated this yesterday, so this is newer. And we're seeing in these top pages an average of 230K of JavaScript, which doesn't sound that bad. This is the download size. I'm sorry, not the download size, the uncompressed size, which doesn't sound too bad, but we've got 2 search pages in there, which are only 20K or less. So, but the really upsetting stat is over 70% of the functions downloaded are not executed by the time of the onload event. So that's a stat you can get with Google PageSpeed. So what it means is 70% of that downloaded JavaScript could have been deferred until after the onload event. Or maybe that's a max, because there might be some error handling JavaScript code in there. Maybe this is running in Firefox. Maybe there's some conditional code that might get triggered in IE. But I would guess more than half of the code that's being downloaded as part of the main page, having this blocking effect, taking time for the browser to parse, is not being used to render that initial page before the onload event. So I think there's a lot of room to do one of the rules in my last book, split the initial payload. I expected a better reaction from that photo. You guys
Steve, I have a question real fast.
Yeah.
How much do you think that percentage of unused code is because people have gone kind of crazy concatenating JS files together? So they have kind of one fairly large one, and so there are only a very small percentage of their page that actually utilizes that functionality.
Yeah, I don't think none of these top 10 sites. I think some websites do that. So the question was like, one of the rules in YSlow in book 1 was concatenate your scripts together. So I've got my first page uses scripts A, B, and C. My second page uses B and D, and my third page uses C, D, and E. So I'm going to concatenate A through E all together and load it on all pages. So I don't recommend you do that, but I don't think any of these folks are doing that. I think, to be honest, one of the things that's really cool at Google is we delete a lot of code. And I think to be honest, my guess is there's a lot of JavaScript that's lingering around that people know. If like you went through function by function, they'd say, oh yeah, that's left over from when we did that campaign, or then we moved over to this new MVC architecture and we never cleaned out that old stuff. And then I think some of it is DHTML. I've got a button I click that pops up a div that lets me fill out an email or something. So I think it's a lot of that too. So split the initial payload and load scripts asynchronously. Okay, so I really got to wrap up. This stuff really works. So Jen, I met yesterday. Hey. So she works at HappyCog, and she mentioned to me, I love it when this happens, she mentioned to me, yeah, like we moved all our JavaScript to the bottom, and like the page got a lot faster. And then there was Ray from Zappos mentioned to me, yeah, we're using Kyle's lab.js to load our scripts asynchronously, and it made our page really fast. He said, we're reading your stuff, we're drinking the Kool-Aid, and our pages are faster. I said, what was the number one thing? Lab.js, we're loading our scripts asynchronously. And then McKinday's talk this morning from Facebook, again, like getting that JavaScript, letting the CSS get in, letting the images get in, render the text in the page, and then adorn with the JavaScript. It's a really good pattern. And it seems kind of simple. I'm seeing a lot of really big websites that aren't doing this pattern. Okay, so now time to wrap up. I wanted to show one thing. I'll just do it really quick. Chris isn't up here with his hook yet. So McKinney was up, and he shows this bootstrapper and bootstrap and load components. And so I wanted to get that snippet for, well, how are they doing the appendChild or insertBefore? So I load Facebook, and I have HTTP watch running, and I set this filter to only show me stuff that has load components in the body. And I'm pretty sure the definition is going to be in this first script response. So I open that in a new tab. I go over here, and I say, let me search for load components. And OK, there it's being called. It's being called. It's being called. It's being called. OK, cool. I found the definition. My work is done. Now all I have to do is look at this code and figure out what it's doing. Yeah, so that's kind of cumbersome. And so I'm like, oh, wait, I remember. So when I did YSlow, there we go. I had this really cool feature that not many people noticed, where you could look at all of the JavaScript in one window. So if I'm trying to reverse engineer some code and I'm skipping across files and inline blocks, it's all in one window, so I can search back and forth. But look at what this looks like, right? I've got stuff like this. And so Stoyan came on, and he did all JS beautified. OK, now I'm going to search for load components. And there's the function, and I can read what's going on in the code. So how many people knew about that feature? So I think it's a really powerful feature, and it kind of talks to some of the eloquent posts that Alex has done about document source and being able to share our JavaScript code. So this code, luckily, is not obfuscated. So when I see the variable names and the function names, I can kind of get an idea of what's going on. And I really, recommend minification, but not obfuscation in general. So this really helps me to be able to figure out what Facebook, in this case, has done in their code and benefit from that. Okay, other news items. So like I said, UA Profiler morphed into Browser Scope. We're adding new categories. We're going to have an announcement in the next week or so. So if you don't know about it, go and check it out, trying to promote a faster, safer, more consistent web experience. I helped get the HTTP Watch guy and the Firebug guy together to create this har format. My contribution was I picked har as the 3-letter suffix for the file name. And I introduced the two guys. That was my role. And so you can get this. There's a plugin called Net Export for Firebug, and it also works in HTTP Watch. And we're seeing more. There are already a couple other tools out there that support the har format, and we're in conversations with a lot of other people. So I think the idea is to have an industry standard kind of hub and spoke syntax. So if we want to share information, have services like Zoom that can load your page and tell you performance information about it, we might want to look at something that we don't know about today, but we find out about next month. We might want to go back for the next 6 months and look at it. How are we going to capture all of these page load experiences? If we don't have an industry standard way of doing it, then everyone's in a silo. So it'll be great to have this industry standard going forward. If you're not going to Velocity, I recommend you sign up. It's an awesome conference. The chairs are amazing. And takeaways. Speed matters. If you want to make the experience faster for users, you got to focus on the front end. Run both page speed and YSlow, give you the most likely things to fix. Really, if you're not doing it now, move towards this pattern, at least evaluate it, of getting all the JavaScript, or at least as much as you can, out of the way early on. And if you would, go and do that stevesouders.com cache.php thing. And I'll do a blog post about the results in the next week or two. And that's it. I think I'm over. Thank you. So I'll take questions until I get pulled. Are there any questions? And I'm going to be very sad if there aren't questions. Jen?
What do you recommend in terms of, if people are loading jQuery from Google instead of locally, and then that's one more browser call you have to make to a different domain, what's actually faster, hosting it on your own where you're calling from anyway, or calling it from there?
So it could vary. It could vary depending on your website, like what your servers are like and where they are, and also the user's connection and where else they've been. But in general, I'd recommend pulling it off of Google's Ajax library CDN, which Dion was a big part of creating. Google's servers are everywhere. They're fast. We've got good peering connections. And initially, when this idea came up, I'll admit, I didn't think the critical mass factor would be that big, but it is. There are a lot of websites that I don't have a number, but just from looking at packet sniffers, there are a lot of websites pulling jQuery off of that Google Ajax CDN. And so now if a user has been to that website and they go to your website, it might already be in the cache. So I think in general, it's worth the extra DNS lookup to pull it down off of Google. No? Yeah?
About the page speed considered in search ranking. So our customers now come to us and say, you need to optimize the onload event. Because that's what's being measured. And we say, okay, we actually want to optimize the felt performance. So do you have any ideas on how that could work together?
What did you call the other thing? The what performance?
The felt.
Oh, the user perception of performance, yeah. So, again, it's like the answer 5 years ago. OnLoad is the best thing we have right now. There's this web timing spec that's that was published about 2 months ago that's now going through, a little revamp that will give us better accuracy as far as that timing information. But OnLoad is still going to be the best thing that we can grab onto. And I'm not so sure, I understand that it's kind of the tail wagging the dog to optimize for that. But I still see out there a lot of websites, not a majority, but a lot of them that trigger user-perceived actions off the onload event, like setting focus. How many of us in the last week have gone to a website, typed our username, tabbed to the password field, and without looking up, had the page onload fire, set the focus back to the username, and we're typing our password in the username field again. So as long as people are doing stuff triggered off the onload event, you really do want to get the onload event to fire as quick as possible. And then that goes, the tail wagging the dog goes to the other extreme. What if people put nothing in their page, make the onload event fire super fast, and then load all the stuff after the effect? And my response to that is, that's more work than it is just to make your website faster. So just make your website faster and your users actually have a better experience. So certainly I think there are going to be some false positives, false negatives there. But by and large, I think it's going to be okay. Kyle?
Just a quick question. Do you think with the new focus on script loaders, of which there are many to choose from, they append scripts dynamically to oftentimes the head, even the Google Async one does that. Should YSlow and page speed still be penalizing on that rule of scripts in the head?
Oh no, that's a bug. Yeah, that's a bug. So what Kyle is saying is you'll run YSlow, and I guess page speed too, and it will try to tell you that you should move your scripts to the bottom of the page like Jen is doing. And in this case, you're loading it asynchronously, so it's actually a beautiful thing. It just happens that that code is in the head, or the script element for that script is in the head. And that's just, I don't know, I haven't thought about how to solve that problem, but that's just a bug. They shouldn't be counting that against you. Yeah. Anything else? Okay, thank you very much.